And then, yeah, so any questions that they might have at 11, I can post that also. So just in case they have questions that you didn't have, but you're interested in seeing what they wanted to know. Bless you, bud. Okay, so you should see my number 3 here. And the questions should be all in the same order. So this should be the one that you were asking about. If it's not, just let me know. Bless you, bud. Are you okay? Okay. All right, so it looks like we have a function, and then we want to find the second derivative in general, and then we want to find the second derivative evaluated at 3 places. So don't let this fraction in the first part throw you off too bad. It actually makes for an easier derivative. So let me write it out over here. So I have f of x equals x cubed over minus 2x squared minus 45x. And I want to find the second derivative, which means I have to find the first derivative first. Now, if it helps on this one, that x cubed over 3, you could go ahead and write that as 1/3 x cubed. If you want to separate the coefficient, it would be a 1/3 fraction. And then the rest, let's write the same. Now, you don't have to do that step, of course, but if it helps you see what's happening when you do the power rule, it can be helpful. So let's take the first derivative. So you guys, you're going to bring the 3 down and multiply it by 1/3. And you guys, 3 times 1/3 is just 1, right? It's just 2 reciprocals multiplied together. So you end up with just 1x squared minus 4x minus 45. And so that's the first derivative, but we need to take the second. So you just do the power rule again. So we're going to bring the 2 in the front, and we'll have 2x minus 4, and then that's it. And I know your question is going to be different, but it should at least be similar to this one that I'm doing. So you guys, I have the second derivative here. It's 2x minus 4. And then it wants to know what's the second derivative at 1. Well, just remember, put this 1 into the second derivative. So you get 2 times 1 minus 4. So 2 minus 4 is negative 2. And then let's find it at 9. So it'll be like 3 different values it has you find it at. So at 9, we're looking at 2 times 9 minus 4. 18 minus 4 is 14. And then lastly, it wants the second derivative at negative 5. Just make sure, depending on what yours ends up looking like, be careful with your negative. What happened? Zoom, I think Zoom is just getting worse as the semester goes on. It said screen sharing has stopped. Cool, thanks. I wasn't done with that. The whole window I was sharing is closed. Okay, here's what I'm gonna do. We had just one more, and we were taking it at negative 5. You guys, it was 2x minus 4 was the second derivative. So if I put a negative 5 in there, you're looking at negative 10 minus 4, and you should get negative 14. Does that help you on number 3? Was that actually the problem that you were having trouble with, or a similar problem? Okay, cool. So yeah, guys, I don't know what happened to the shared screen, but on that last part, I just put negative 5 in for the x on the second derivative. While I'm waiting for the next question, I will go in and pull that back up because I don't know what happened to it. Okay, so I've got the practice exam pulled back up, ready for any other question numbers that you guys have. Seven? Okay, I can work on 7. Okay, so 1, 2, 3. Oh, I could do this in an easier way probably. There we go. Okay, so on number 7, we're looking for absolute extrema, so absolute min and max. On an interval, notice our interval is closed from -5 to +5. You guys, the only on a closed interval do we test our endpoints. So that's something to keep in mind as we go. So what you're going to do, remember chapter 12, you're always going to be taking the derivative, at least the first derivative, sometimes the second. On this one, we're only needing the first because we are going to look for critical numbers. So you guys remember, on a closed interval, you look for critical numbers, and then you test any critical numbers that are within your interval as well as your endpoints. And because the interval is closed, remember, you test them in the original function. So this is the one that's different. All the others kind of work the same way. This is the one that works differently. So the first thing you want to do is take the first derivative. So on my example here, my first derivative would be 4x cubed minus 64x. And then you're going to set that equal to 0 to get your critical points. And yours is going to turn out in a similar way where at this point, you're just going to be able to take out the greatest common factor. So on this particular problem, it won't be like the quadratic factoring or anything. It'll just be like this, where what's the biggest thing I can take out of both of these is a 4x, which will leave me with x squared minus 16. And then you set each of these factors equal to 0 to find your critical points. So 4x equals 0, so x equals 0. And then over here, x squared minus 16 equals 0. You guys, you are going to get that squared term on this question, and you're going to have to square root both sides. Make sure that you consider plus or minus on this one. So in this case, I have plus or minus 4. So you guys, I have 3 critical points. I have 0, 4, and -4. I'm going to consider my interval that goes from -5 to +5, and notice that all of those critical points lie within my interval. So I have to test everything. So you guys, let's set it up. I'm going to test -5. Remember, test your endpoints also. -4, 0, +4, and +5. And you guys, so make this list of values we are testing, and then test them in the original function. So that test is really just finding y values at these points for the original function. And then after I find them all, I'm just going to compare them. You guys, which one's bigger, which one's smaller? And those will be your absolute max and min. And remember, you can have multiple max and min spots. So let's see, let's start at -5. So you guys will have -5 to the 4th power minus 32 times -5 squared plus 256. Let me get my calculator out with the big numbers. All right, so 5 to the 4th, 625. So you know that's positive 625 because we took it to the 4th power. This is minus 32 times 25, and it'll be positive 25. So this is minus 800, and then we have plus 256. So we end up with 625 minus 800 plus 256. I got 81. So you guys, I got 81 here. And then let's do -4. So -4 cubed, or sorry, to the fourth, minus 32 times -4 squared plus 256. So -4 to the fourth is positive 256 minus, you guys, this is going to be positive 16. So minus 32 times 16. So minus 512 plus 256. So you guys, what do we end up with there? Isn't that just going to zero out? It does. You guys, we just get a 0 for this one. All right, so the bulk of the harder part of this test is over because I can be a little bit clever on the next 4. So obviously, testing at 0 is pretty easy because if I put x in for all these zeros and I'm looking at 0 to the fourth minus 32 times 0 squared plus 256, what's left over is 256. And guys, notice that every x in the original function is raised to an even power. So because of that, your value at -4 and +4, and then the same with the 5s, is going to be exactly the same, right? Because your negatives went away when you squared and when you took it to the 4th power. So notice, and make sure you understand why your value at 4 is going to be the same as your value at -4. And your value at 5 is going to be the same as it was at -5. Now you can obviously work those out too, but just using what I know about powers, I know that this is the case. Okay, so the question, and you can see part of the question here. It says it has an absolute minimum at, and you can see how they wrote their answers. You guys, it's looking for the x value. So it says it has an absolute minimum at what x values. Notice that the absolute minimums here are actually these 2 zeros. So those are the 2 lowest values that you found. And they occurred, so the minimums occurred at 4 and -4. So you'll just write both of them with a comma in between. And then it has an absolute maximum at 0. You guys, the highest value happened at 0. So because of the at, and it says x equals, make sure that your answers are just the x values. Like the absolute max value is 256, but they didn't ask me for that. They wanted to know where it was at. Well, it's at x equals 0. So just be really careful. Give x values as your answers on this one. And if you have more than one, it's okay. Just separate them with a comma. All right, what else we got, guys? What, sweetie? I'm not done. $17. All right, guys, we're gonna look at number 17. Where am I? Oh, I just have to share again. That's okay. All right, number 17. You guys, so this is a related rates problem, so something we just looked at. You guys, it says that we have the volume of a cantaloupe, and it gives you that formula. So we've used this formula quite a bit. Well, we used it once at least. Anyway, you guys, it gives you the formula, so it's not something you have to remember. But the reason it's giving you this volume formula is because it relates the volume of this cantaloupe with the radius of this cantaloupe. And what I do know is, look, the radius is growing at a rate, you guys. It's about to give us dr/dt, how radius is changing over time. You know it's the time question because it says rate. And it says 0.9 centimeters per week, so we're going to use 0.9. We are going to use positive 0.9 because it says it's growing. It's not shrinking. That would be weird. But anyway, you know, sometimes things are, we have to see if it's positive or negative change. This is positive change because it's getting bigger. So I know it's growing at this rate, and I also know at this time the radius is 7.8 centimeters. What it wants to know is how fast is the volume changing. So it's giving me dr/dt, but what I want to find is dv/dt. So that's why I have this equation here. It's a relationship between r and v. I'm going to write this out, you guys. V equals 4/3 pi r cubed. And you guys, this question, being a related rates question, you're going to take the derivative of everything with respect to time. So you guys, keywords on this one, because it never just says, hey, use related rates to find this. I think the word rate and how fast is it changing, you guys, that's asking for a rate, should help you clue in that we're looking for a rate here and using this related rates process. So we have our formula that relates R and V. We take the derivative of the whole thing with respect to time. See, guys, this is just a V. So dv/dt is the derivative of volume with respect to time. Equals, remember that both 4/3 and pi are just constants. They're just numbers. So when you do the power rule, r is your only variable over here. You bring your 3 down, multiply it by 4/3 pi. Well, you guys, these 3's cancel out, and you're going to be left with 4 pi r squared. Now, once you've taken the derivative with respect to time, now you can plug in the information. Oh, hold on, I forgot something. Don't forget that. I almost forgot what we were doing here. You guys, don't make the mistake I almost made right here. I got the 4 pi r squared and then, you know, was going to go along my merry way. Everything gets a dt, right? So be careful. And also, if you didn't have that dr/dt in there, where would I put this information that they gave me? So be careful, everything gets a dt. But once you actually have the derivative, now is the time to put in the information that they give you. So we don't know dv/dt, that's what we're looking for. So dv/dt equals 4 pi. Go ahead and put your r of 7.8 in here. So times 7.8 squared times the dr/dt they gave you, 0.9. And then from there, it's just using, just doing the math, right? Make sure you square the 7.8 first, or whatever your number happens to be. It'll be a little different, surely. So you guys, I've squared the 7.8. Now I'm going to multiply that by 0.9. And let's see, it does want it rounded, so I'm going to go ahead and now multiply that by 4 pi. And you can see what the answer is over here, but when you multiply all this together, you should get 688.1 because it says round to 1 decimal place. just make sure when you're doing that problem and you're using your calculator, use the pi button. Don't just say, oh, pi is about 3.14 and then use 3.14. Your decimal will be off if you do that. So actually use your pi button in your calculator. So yeah, clues on related rates, guys. Let's see. Everything gets a dt. And after you take the derivative with respect to time and give everything a dt like you should, you're just plugging in values. Just make sure that like this r, don't put it in at the beginning. You know, you have to take derivative first before you start putting stuff in. Anything else, guys? So I am recording this, so I'll post this. So the questions that I did answer, you can go back and look at them. Oh, okay. So one by one. Okay. Maybe if we start, okay, so we definitely won't have time to go through them all. Maybe if we start, let's see, what's giving you the most problems, you think? Do you think it's the stuff like at the beginning of it or at the end? Because we could start at one end and try to go through problems that way to see, I want to get through any that would be most useful for you, I guess. So would you say you need more help with like related rates and implicit stuff, or maybe the stuff from 12.1, 2, and 3? Start at the beginning? Okay. That's probably a good idea because we haven't done that stuff in a while. Okay, so this is number 1, guys, and we'll see how we can do. Choose the correct increasing and decreasing intervals. Make it a little bigger. How big does it go? That's big enough. All right, so just remember, so this one, it seems simple because you're just looking at a picture, right? Increase means you're just picking where it goes up and down. Down is decreasing. But just remember your intervals have to be in y values. All right, blah, blah, blah. Pretend I never said that. You guys, I don't want to confuse you. Your intervals have to be in x values. I don't know why I said it like that. I think my goal was like, I was either going to say put them in x values, or I was going to say never put them in y values, and it just came out in the worst possible way. Your interval has to be in x values. Okay, so let's find some increasing intervals. You guys, let's find out where this graph is moving up. Remember, it's moving up as you move from left to right. So you guys, this interval here is moving up, and this one here also. So in x values, look, it starts increasing here at -2, and it stops increasing here at 0. It starts increasing over here at 4, and it does not stop increasing. It looks like it might stop increasing because the graph gets cut off, but you guys, at that point, it never stops increasing. So notice how they have the answer here, increasing from -2 to 0, and increasing from +2 to infinity. And then let's see what they did for decreasing. So let me clear my increasing intervals. Ooh, or I can put them in a different color. Guys, I didn't know I could do this. Oh, that's too similar. Let's do a blue. My pen just happened to roll over that section. Oh, it's already blue. There we go. Let's talk decreasing, guys. Ooh, we're decreasing here, and we're decreasing here. So in x values, notice that all of these x values over here, as the graph is anywhere over here, it is decreasing. So it's decreasing here from negative infinity up to -2, because remember that's where it stopped decreasing and started going the other way. And then also it starts decreasing again at 0 to +2. So you can see how they got those there. Now, remember what local extrema is and how to find it on your graph. So it's just going to be any relatively high or low points. You guys, we have a high point right here. No, it's not going to be the highest point on your graph, but it's locally high, relatively. And then we have 2 low points. So any hill, any place where the direction changes, you're going to have these extreme values. So it wants to know the x values where they occur. So the max occurs at x equals 0. And these 2 minimum values occur at -2 and +2. So notice, just make sure we don't get it switched up. The local minimum at x equals -2 and +2. Notice it gives you the value of the minimum. The value is 0. They occur at negative and +2. For the max, that max value is 16, and it occurs at x equals 0. All right. I like the purple. All right, so this one is just finding any local extremum, which just means local min and max. How do you know where those occur? Well, you guys, they occur at critical points. So the first step here, oh, I gotta draw, not click mouse. Okay. The first step here is to find the first derivative. So what's the first derivative here? It's going to be 3x squared plus, when you bring that 2 times 2.5, it's going to be 5x minus 12. All right, so we need to set this equal to 0. And I know from here, guys, this is a factoring situation. So just remember, there's a lot of different ways we can factor. You pick your favorite way. Remember what I do? I usually do like 3x and 1x here because it has to be 3 and 1, right? We do have choices over here. So what about 6 and 2 maybe? Well, no, that's not going to work because why? Because when you check it on the cross, it's going to be 6 and 6. That doesn't make any kind of 5. Oh, eraser. So what else? Maybe 3 and 4 somehow? What if we do 3 and 4? That should do it. You guys, why is, which one needs to be negative? I think it should be the 4. You guys, why did I pick what I picked? You guys, because when I check on the cross products, 3x times 3 is 9x. 1x times -4 is -4x. When I add these together, so when I cross product and then I add those together, I get 5x, which is what I have in the middle. So, you guys, I'm going to write this as 3x minus 4 and x plus 3. And then I'm going to continue by setting each thing equal to 0. So I've got 3x minus 4 equals 0 and x plus 3 equals 0. So 3x equals 4, divide by 3 and get x equals 4/3. This is one of my critical points. Minus 3, so x equals -3. That's my second critical point. Now, I do have to say if they're a min or a max, because it doesn't just say in the answers 4/3 and -3. You can see those, but you have to test them. Hey, turn your sound off, bud. I told you had to turn it off if you're going to be in here. So you guys, I have to test to see if they're a min or a max. Now this is your choice. I never am going to specify on the test that you have to use the first derivative test, remember the one with the number line, or the second derivative test, which is a lot faster and easier. So I would suggest the second derivative test. So remember, what that means is I need to take the second derivative going from the first. That's going to be 6x plus 5. And you guys, from here, what is the second derivative test? Well, it just means that you take your critical point and put it into the second derivative. And even though one of these is a fraction, usually it turns out pretty easy to deal with. Like in this case, guys, this is 6/1 times 4/3. Straight across the top, straight across the bottom, you get not 26, guys. What? How about 24/3 plus 5? 24/3 is just 8. And you get 8 plus 5, and you get 13. So what does it mean? I put 4/3 in, and I got a positive value. Remember what this test says. Positive second derivative means concave up. This is what a positive second derivative does. And I got a positive value, which means at this critical point, my graph is concave up. That tells me that this is a minimum. And then let's go ahead and test the other one. Honestly, that's probably enough information to get you the right answer, seeing as it's multiple choice. But let's use the test on -3. So you would put -3 into this second derivative and get -18 plus 5 and get -13. Well, you guys, what does it mean when the second derivative is negative? A negative means concave down. So the positive goes with the word up and the negative goes with the word down. So that kind of makes sense. It means at -3, this is what the graph looks like. So you can see that -3 is a max. Okay, guys, I'm just going to stop trying to write what I'm saying because it's not working out today. Okay. So you so take the first derivative, find critical points, then take the second derivative and test those points to see if they're a min or a max. We did number 3, I think. Yes, we did. Number 4 is very similar to number 3, but it's got the e term in there. So this is just a second derivative problem. So really you just have to remember how to take derivatives with the exponential function in there. So I've got -6e to the 4x. So let's take the first derivative. All right, so the first derivative here, now the -6 just comes along because it's a coefficient. Remember how to take exponential derivatives. This e term always comes down exactly as it is. Everything comes down. And then, as my second step in the process, I multiply this by the derivative of what's up here, of the exponent. So the derivative 4x is 4. And you guys, you can put these two numbers together and call this -24e to the 4x. Okay, so remember, I can't stop there. I've got to now find the second derivative. But the method's going to be basically the same. This time I'm going to bring down the -24. And I'm also going to bring down the e to the 4x just as is. And then I'm going to multiply the derivative of 4x. So each time it's just getting bigger by a factor of 4. So then we'll have -96 e to the 4x. Now, when you put in values here, notice that it's not going to have you calculate these out when they're like a crazy number. So it asks for f of 0, or second derivative at 0. Well, let's do that, guys. We get -96 times e to the 4 times 0. So that's negative 96 e to the 0. You guys remember anything to the 0 power is just 1. My hands today are writing all over the screen. So because that's just 1, see, and now it's not erasing. There we go. E to the 0 is 1. And you guys, so negative 96 times 1 is just negative 96. So you can see that that's what they got here. But notice what they do on the other one. So that one's easy to actually calculate exactly. But f of, at the second derivative at 5, that's going to be negative 96 times e to the 4 times 5, which is negative 96 e to the 20th. And instead of putting that in and getting a calculator answer, notice it says write your answers exact. So you would just write that, negative 96 times e to the 20th. And then on that last part, looking for the negative 4, we'd have negative 96 e to the 4 times negative 4 and get negative 96 e to the negative 16, and you would just write it in like that. So yours will be very similar, of course, not the exact same numbers, but the same methods here. Number 5, very similar to the one on number, was it 2? You guys were going to find critical numbers. You're going to test them in the second derivative. So this one's pretty clear. It's just like number 2, guys. Take the first derivative, set it equal to 0, find your critical numbers. This one's probably even easier, to be honest. And then what are you going to do with your critical numbers? You're going to take this second derivative and you're going to test them in the second derivative. So to save us a little bit of time, we won't do that one since it's the same. All right, so let's look at this one, guys. Notice it's asking about concavity, concave up or down. It wants to know where those things are happening. So it also wants any inflection points. So I need to find these values, which means inflection, concavity, that is all about second derivative. So here is your original function. I'm going to write it over here where there's more space. And then I want to take the first derivative, bring the 3 down, we get negative 9x squared plus 2. Let's find the second derivative. And we get negative 18x. All right, so this is the second derivative. Now, the first thing I would do is go ahead and find inflection points. So how do I find inflection points? Remember, critical points is where you set the first derivative equal to 0, but inflection points, we get to set the second derivative equal to 0. So just make this 0 equals negative 18x. So what do we get for your inflection point here? Isn't that just 0 when there's just 1? And notice it says you're going to be looking for, and it will remind you, it says type an ordered pair. Once you find this 0, how am I going to find the y value that goes with it? You guys, anytime you have an x value, no matter how you found it, to get the y value at that x value, you just put it in the original. So you guys, if we put 0 up here, what happens? This is gone, and we're left with 7. So, and again, it'll remind you to type an ordered pair. It wants the x and y value there. And I know it's real wishy-washy when it wants a point and when it wants just one of the coordinates, but luckily it kind of guides you on that. So you guys, the inflection point is 0, 7. How do I know where it's up and down? Well, you guys, the inflection point, remember that's where it changes from one to the other. So here's 0. And it's not, you probably don't even need to really make a number line on it. But you guys, remember that for concave down, so looking like this, if it's concave down, your second derivative is negative. And for concave up, it's positive. So you know that 0 is where it changes from one to another. So just think, if you're looking at a number for x that is less than 0, look, -1, for example. What happens when you put -1 into here? You get -18 times -1. Isn't that going to be positive? You guys, which means all of these values over here, if you put a negative value for x in, it's going to cancel out that negative on the 18, and you're going to be looking at a positive value. You guys, which means if you put in a positive value for x, like 1, for example, because it's positive, this negative stays, the one with the 18, which means your answers will all be negative and you'll be looking at a concave down situation. So using your inflection point as the place where it changes, just see what it is on each side. And the derivative itself is not going to be any more complicated than this one is. So it's just like, okay, where is it positive? Where is it negative? So notice what it has here. We're concave up like we have in this picture here, from -infinity all the way up to 0. And then it changes to concave down on the other side from 0 to positive infinity. Make sure you don't use brackets on any of these. Let's see, I know we did number 7. So it looks like we have time for, well, honestly, this one's really fast. We might get 2 more in. You guys, so here is x cubed plus y cubed equals 5. We want to do implicit. Remember implicit, you take the derivative of everything. So we're going to have 3x squared. Remember, y works the same as x for the most part, plus 3y squared dy dx equals 0. You guys, don't let these confuse you with the related rates. Just remember, related rate, the word rate means everything gets a dt. And then implicit, you guys, that's just y getting something extra. So here we are, you guys. We're just trying to solve for dy dx. So you're going to subtract 3x squared from both sides and get 3y squared dy dx equals -3x squared. Divide both sides now by 3y squared and get that dy dx equals, let's see, what would that be? -x squared over y squared. You guys, this is your implicit with a product rule. So I've got xy squared equals 4. So you guys, product rule, u equals the x, v equals the y squared. So du is just going to be 1. dv is going to be 2y dy dx. So let's put it together. We get x times 2y dy dx plus y squared times 1 equals 4. So remember, you're just trying to get dy dx by itself here. So let's go ahead and subtract y squared from both sides and get x times 2y dy dx equals 4 minus, oh guys, what am I doing? Where's my mistake? Surely you see it. I was thinking this one was turning out super weird. What did I do?
Take the 4 to 0, maybe?
Right, exactly. See, this was a teaching moment. I meant to do that. You guys, the derivative of 4 is 0, and I didn't take the derivative of that side. I just wrote it as a 4. So yes, so be careful. So we are going to minus the y squared, but it's minus from 0. So we just have minus y squared over there. So what do I do next? Well, this is x times 2y times dy dx. So now I just need to divide both sides by x times 2y. Or 2xy, or however you want to write that. So I get this over here. Now notice I can get rid of one of my y's. So I can say this is just y and this y is gone. And I can have negative y over 2x. All right, you guys, I think we need to stop there. So honestly, this one we were about to do is very similar to the one we already did, that first implicit we did. So guys, so just remember, get your practice exam done. Take it, there's no reason to not get 100 on that. You guys take it, practice it until you get it all right. You're going to be so super prepared for the test if you do it that way. And then I am going to open the test here in a minute. You'll see it. And I will open that assignment in D2L where you can turn in your work. So make sure you do that. And let's see, if you do have any more questions to ask me, make sure you either take a screenshot of the problem you're working on or you send the email instructor thing through the question like on MATLAB, because now that the test's open, I'm just going to be having to be very careful about the questions I answer, basically. I don't want to take your test for you. So, but no, that's it, guys. And then I'll record my next session too in my 11 o'clock class. They might have different questions. So if you might want to check that out later. I'll post that on our page too, just in case they have questions that we didn't answer here. Alrighty, so good luck on your test, guys, and I'll see you on Monday if I don't talk to you before then.